back in session 8. And if you look closely, you can see you might be in a different lecture today. You see the difference? So, any guesses what we are talking today about? Of course, about the Internet of Broken Things. But what does that mean? What? Oh, that would be a good thing. No, it is, but it's kind of a part of it. Yeah. So bugs play a big role in what we are doing today. But what might the Internet of Broken Things entail that we talk about? We talk about security and privacy today. You're lucky. So the last time I did this lecture, we actually did a lot of research in the class and we did a debate. So I will try something different today, which includes a little bit of lecturing. So you guys can kind of relax and listen to me doing something. Now you have to write things down. Don't for you know me, so you still have to write things down. But so what we will do today, we talk about the Internet of Broken Things. So first I want to actually show you what is broken. And then there will be, in the end of the lecture, there's a part where we think about things, how to fix it. So basically, I will be the bad guy today. I will say everything is broken, and you have to convince me that it is not. Yeah? So later you do a little bit of research how we can fix things. So now hopefully we can end this lecture on a note that we will all together pay attention that we don't make the Internet of Broken Things and that we all work on fixing it. Yeah. So you know the introduction, we have 20 to 50 billion connected devices already in 2 years. So what could actually go wrong? So I want you to kind of do a tiny bit of research now in the beginning and think with me or Google what actually with so many devices and the things you have seen actually could go wrong. Yeah. So just write down either from your head or with Google what is already broken, what you think will break, and why. Yeah? So, very quick warm-up, 4 minutes to think already what you already know what is broken. And then I scare you a little bit more after that. Good. What could go wrong with 50 billion devices? Anything? No, it's just okay, yeah? Is anything already broken? Have you heard about some stories, kind of scary stories, connected to the Internet of Things? Or Google just some now?
The Nest thermostats were causing the had a Wi-Fi issue and were causing everyone was freezing in their homes.
Cool, because I didn't hear of that one yet.
And also the pipes, some of the pipes were freezing just because in the cold areas, also the water pipes were freezing because it was too cold.
Cool, yeah, nice find.
Hackers hacked an IoT fridge. And
Okay, why would you buy one anyway?
This is used Apple website.
Oh, so yeah, you basically had porn on your fridge? Oh, that's that gives kind of poning somebody. Interesting story. Hey, good. I also didn't know that one. So you have some others? Oh, just think from your head. So well, you have trouble kind of managing 4 Vimoses. So imagine a company wanting to manage 1 billion devices. Do you think they can?
There's sometimes lack of experience from the users, so they don't know what they handle with.
You are just so nice people. You blame the users. Anybody wants to? Yeah, sure. They don't have experience and they don't invest. They just want things to work. They just want convenience. Yeah, that is a big issue. Anybody blaming some companies here? Guys, be critical. All right, okay, we will go in there now, yeah? So, I will lecture now, as promised, yeah? Even if I don't do that usually, but of course, you should not just sit back and relax. So I want you to write something down. So you can actually Google while I lecture. Yeah, I actually like that. But if it's in the topic. Yeah. So I will present a couple of threads. But of course, I can't go totally in depth. So please feel free to kind of follow up and read up on Wikipedia while I actually address some of the things here. And add some notes to it. So what is not, basically, if you have a comment or an addition and you see something online which I forgot to say or which is important for you, write that down. Or write down some notes about what I actually say. Also, while I talk, because you think faster than I talk, start reflecting on what I say. So some of the things I might say, you would say, that's not so critical. So maybe that's already not an issue anymore. So a little bit, you should question and think what I present, is that still a big issue? And look if there's things I forgot. I forgot already 2 of the ones you presented now. So kind of start off with there. And especially try, when you find a thread, to Google if it is still a threat, if maybe there was a firmware update which fixed all the issues and so on, yeah? Or how likely would something like that happen again? Okay, so keep that in mind, yeah? Basically, Google things I present, try to find more on Google, and think about the solutions, yeah? Because you later have to fight me in convincing me that the internet is not too broken yet and that we can continue working with the Internet of Things. So, because, and this is why I said companies, so I'm kind of a little bit nicer here, not blaming everything on the user. I think companies are to blame too for breaking the Internet of Things. And because companies also always assume they can do updates for tons of devices which are somewhere installed and then they can fix it. And you have seen how great Android phones are updated, yeah? There are millions of Android phones out there which, which are still running, I don't know, KitKat or something like that. No? So tons of security issues was right there in the phone. So now, and the phone is a pretty powerful device. Now think about, yeah, webcams, think about routers and all that stuff. So do you get ever automatic updates there? Is there any policy how these things get updated? So I think in practice, companies don't update your devices frequently enough. And I think they cannot manage. So I think it's actually a bigger task than that. The idea is only to get the devices out quickly to you, sell them, but there is nothing here with updates. So then, if things come into your house, which are wireless, the companies usually assume you put them on the same wireless network as your other devices. So that brings basically the possibility of Trojans and kind of things which can go into your network right into your house. Yeah, so if you have an unsecure device which kind of talks to the internet and it is hacked, you have something in your private network where you all do your stuff. So even your router doesn't help you when firewalls you off because you have put the device, you put your Alexa just in the same network as everything else, or your Google Home or any other smart hub. Then people don't change people hate passwords. You might have heard that Microsoft is actually doing a huge initiative to totally kill off the password. Passwords are one of the worst security measurements ever invented, especially passwords which change very often. So there's a lot of research now about that you make things very insecure if you force people to change their password. Yeah, seems counterintuitive, but please feel free to Google. There's a great white paper from Microsoft talking about how insecure it is to change your password, or to be forced to change it too often. Then, yeah, if you start talking about privacy, things are completely broken. Yeah. So, because basically, to use your devices you buy, you have to allow them to totally monitor, control, and be in your private environment, because else they just don't function. And a kind of big thing which I try a little bit to address with Ulno IoT, is that everybody thinks they have to do a star topology. Yeah, so we have something in the cloud, and everything else talks to the cloud. And then you have single point of failure. If the cloud services suddenly don't work anymore, the company goes bankrupt. You have all these dead devices which kind of never get updates. So there's a lot of trouble in the idea of using star topologies with Internet of Things, but it's the predominant architecture used with the Internet of Things. So, give you some really hard examples now. We will talk about zombie webcams and the zombie networks in a specific case where that happened. We will talk a little bit about Wi-Fi, so that's another issue here. Basically, most of you are thinking that they are using protected Wi-Fi, but I will show you that it is not very protected. And I bet, so I experience the DOS attack a lot in the Rapheim at the moment. So there are a lot of people who use that to kind of gain control and kind of let other people not use the Wi-Fi at the moment. So Wi-Fi is everywhere, but with this comes big problems, and especially we have nowadays a security standard in Wi-Fi networks which is from 2009. So you basically on every Wi-Fi device you find nowadays there is at least this standard in there, and that's pretty old. And not even, so actually even older. So this IEEE 802.11w is maybe not even in, less than there might be about 30% of the devices which still don't have implemented it. Especially I will talk about the DAuth attack and the Krack attack in Wi-Fi networks. And there's a big topic lately coming up which is very relevant for us, which is cyber abuse, which is some kind of social thing. It has nothing so much to do with technology, but we have, as technologists, we have to think about cyber abuse in this context. And then one of my favorites, which kills basically everything which is out there, which is the man-in-the-middle attack. Most of you probably know what it is, but we will revisit that and talk about the consequences here. So, I think it might be already 3 years ago, there was a big hack of security cams and baby cameras, because they're always running kind of a really outdated firmware with default password, and there was a hacker taking over 1 million of these cameras and attacking a security guy. So basically they made a big denial of service attack to a website which talked about security issues and basically took down this website in a very short time. However, this can not only be used for taking down websites, any infrastructure which is exposed to the internet or anywhere where there are lots of these devices in an internal network, it can be used to do denial of service attacks. So imagine this happening in a factory, imagine this happening in a health system, in a hospital. If you basically take down machines in there, this can cost lives. And we just ignore these cases. So you all know the Vimos D1 Mini. So if you pair that one with a battery and a button, you can build a Wi-Fi jammer or a de-author, or however this is called. It's just a firmware you can download, and you can basically disconnect everybody who doesn't support the new, or you can disconnect everybody who doesn't support on the router and on their client device the new IEEE 802.11 standard from the internet. So you basically press a button, everybody goes out of the internet. You're pretty safe with your computers because Windows and Mac have this updated, but lots of old versions of Android, for example, don't have the update, and they will be also disconnected. And if your router doesn't support it, you are still vulnerable. That also means that basically 95% of devices in hospitals are vulnerable to it. So you can walk with such a device into a hospital, and device which has Wi-Fi, you can actually attack with this. Lots of devices actually crash then when you attack them with this. And again, so if this is a live supporting or a monitor thing, then this can be very critical for somebody's life if you do that. Now, if you are in a dorm, you might be tempted to build such a device because there's so many Wi-Fi networks and it takes down your bandwidth. But you never know what other important Wi-Fi devices you might actually damage with. So some devices actually do crash if they are exposed to a DOS attack. So yeah, that might be not so harmful if we do this test-wise here in the university. I'm pretty sure it's very illegal also in Austria to build such a device, so we can only talk theoretical about it. What you try at home, I cannot control. But thinking about these more kind of denial of service-oriented attacks is something we usually like to ignore completely. And this, again, if this is critical infrastructure, can be seriously damaging, especially as you don't need access to the Wi-Fi network. So even if it's a protected Wi-Fi network, you can basically disconnect everybody in this network, which can have serious consequences, especially if we talk about Internet of Things devices. So, however, if you use the Raspberry Pi Gateway and the Vemoses, they both have a patch for this, so they're actually immune to it. But there are lots of devices which are not on such a high level of firmware. That one was actually, anybody here knows the Krack Attack? Have you talked about it? Anybody heard about the Krack Attack? Yeah, basically most WPA2 networks are insecure, and you can, with kind of using the DOS attack we have heard before, you can bring them into a mode that they basically give you the key and you can read everything sent out on the network. So basically there's an attack. If you Google Krack Attack or go to the links I have here, you can build something which allows you to read everything which is sent on in clear text on a WPA2 encrypted Wi-Fi network in clear text. So imagine, again, hospital case with lots of patient data which is communicated in clear text forms because people think, yeah, I can send things in clear text inside the network. Then if somebody maliciously enters this network with this attack, can actually read everything going over this network. Yeah, so WPA is not really safe encryption. So what is the mitigation here? Yeah, use a VPN inside the network, use extra encryption inside the network, then it isn't a problem. Or update to a new Wi-Fi standard where this cannot happen. Again, the new firmware I use is immune to the Krack Attack. Most of new Windows and Apple computers are immune to the Krack Attack. But as soon as you have some old devices on it, forcing the old protocol, even your device might not be immune anymore. So you have to basically make sure that all the devices on that specific network are patched. Coming to one of my new topics I have in this security talk, which is cyber abuse. Have you heard about cyber abuse? So imagine you live with somebody, so most of you are young and have not yet a partner they live in a house with, but of course you share a lot of digital identity stuff. If you have a family, if you live together in a union somewhere in a house. And usually in the house you will have some more technically inclined people and some less technically inclined people. So you guys are probably usually the ones of the more technically inclined people, so it might not be you who is abused, but you might be tempted to become the abuser in some of these settings. So there have been a lot of cases reported where families broke up and then suddenly the lights kind of behave weirdly in the house. Suddenly cameras are on which weren't on before. Somebody looks at your Google history, so at your shopping history on Amazon. Suddenly you buy things you didn't want to buy. suddenly you cannot pay your bills on the bank anymore because the password has been changed. So you can see, if you are the technically inclined person of a household and you get kicked out, you can cause a lot of damage with the digital information you have. And I think the threshold is not very high that you might use your power here in a way that's not intended. So that we have never really thought about that. So everybody just wants us to get together, makes things buying easier, makes things more convenient, but they're never exit strategies. And it's really hard to say, okay, if we split up, then automatically the system will detect that and see, okay, these things belong to this person, these things belong to that person. So there's never easy ways apart from going to a lawyer to actually split up. And even the lawyer just wants to also earn money in these processes because it's so difficult to separate accounts and separate the digital identities. Yeah, or sometimes it's just spying on people. So sometimes it's just gathering information. So it's not even hindering the life of persons, but there might be just information which doesn't belong to the other household participants anymore. And even kind of children leaving the house might cause soon a really big problem because, yeah, I can probably control everything my parents have at home if I wanted to. So if there would be not a good relationship between us, that could be bad. Or look, think about a company. You are an IT guy working in a company. You might know a lot of insider information and might be bound to the digital identity of the company, and you can still wreak some havoc if you wanted to in the company if they kick you out. And don't think about in how far you influence the Internet of Things related stuff in the company. So, and now the kill it all, man-in-the-middle attack. So we all know that we deal with very restricted devices in the Internet of Things. Do you all in principle know what a man-in-the-middle attack is? Yeah, so you have basically here a victim and the web server thinks they are communicating with each other, but in reality the victim communicates with an attacker connected to a web server. So, big issue is now when they start exchanging secrets, keys and stuff to access. Do you know what usually the mitigation is to make this communication secure? Or even make this communication work in a secure way, even if there is a man in the middle? What is the strategy we usually employ to secure and prevent man-in-the-middle attacks? And certificates, signatures and certificates. The signature alone isn't enough, but you need kind of global accepted certificates. So there needs to be a third party which is trusted. You need a trusted third party against which one you can evaluate a certificate. And you always hear about certificates coming out of hand and then people using these certificates to create fake trust and using this as a man-in-the-middle attack. So basically, if I use DDoS attacks in your home and force your devices to connect to some kind of fake router I set up, and these devices don't do certificate validation, then I can basically get all the passwords on the asymmetric encryption which happens in between. Yeah. So funny thing is actually symmetric encryption here is less prone to this attack than asymmetric encryption. So for symmetric encryption, you just have to get to the device, physical access to the device. You might be able to actually get the key out there. But with asymmetric encryption, you have a key exchange, and the man in the middle can actually be in the key exchange, and you are only allowed to change the keys you need for the actual, because then the symmetric key is actually going via the network, and if the man in the middle can actually read the symmetric key, because he faked some of the certificate in between, he has the complete way of controlling the communication. Yeah? So if you don't do certificate validation, do at least a fixed symmetric key communication. So, but okay, that's kind of also insecure because then you have to, both sides need to know the key, and then there are other ways to attack them to actually get the key. So why is this so relevant for us? Basically, most Internet of Things devices are not powerful enough to do certificate validation. Certificate validation is super expensive and needs a lot of memory. There is no easy way to do certificate validation on the ESP8266. So people don't do it. People do symmetric keys and say, okay, we use now HTTPS, we are secure. No, if you can't validate the certificate, you can attack this and read the keys which are actually handled out for the communication. So if you cannot do certificate validation, then you are in trouble. You can use some static certificates, which helps a little bit. So, but this is then in the end, again, a very symmetric setup. So if you don't have a third-party server from which you can validate the certificates, you have an issue. And even there, with DNS spoofing, you might be able to get in between with the man-in-the-middle attack. Man-in-the-middle is a very difficult concept, but one of the most dangerous attack vectors we have in the Internet of Things. So lots and lots of devices are vulnerable to it. It's a kind of hard attack. So actually, you have to do lots of steps to actually get a device to connect to you, and then being connected to still the normal network, and then being in between. So it's a lot of effort with it, but it gets easier to do this attack. And so you should try to protect it. I have actually supervised a couple of theses here which dealt with this issue for mobile phones. I think it's better now on Android, and it's easier to write apps which do certificate validation, but there's still a lot of apps out there which don't, and then you can basically read everything in clear text what they sent around. Okay, so I hope I scared you a little bit. So now you have to defend. I give you a little bit time to address this issue I had, and I want you to think for 15 minutes how to fix these issues I had, if these things are fixable. You want to actually convince me that we don't stop now. So my hypothesis is we should abandon all work with the Internet of Things and only focus on classics. So just do a little bit with mobile devices, but forget all these kind of small devices which kind of are in factories, our home hold, in industry, in automation. No, that's way too insecure. Just do big computers, big robots, just control everything with Windows 10, and don't use any small device setups. Yeah, so that is way too insecure because of the threats I've just shown you, and there are more threats, of course. Yeah. Good. So 15 minutes. Come up with 5 action points. Yeah, that when addressed will fix the Internet of broken things I've showed you so far. And in addition, I want 2 arguments which make us continue to use and build the Internet of Things. Yeah, so you are the good guys now. You have to convince me that it's not all doom. Good. 15 minutes to research that. Of course, these action points and arguments have to go in there. So after we do this research, I want you to discuss with your neighbor for 5 minutes and combine these points and integrate these action points in a list of 7 points and merge that. How much time do we still have left? I never know how long this lecture takes. 11:15. Oh, that works, I think, pretty good. So 15 minutes this, 5 minutes talk with each other, and then we discuss together. I invited 2 students to help me actually to come to the dark side here and help me defend that everything is broken with the Internet of Things, and we will never be able to build an Internet of Things. So to have a little bit of protection, because there are too many students here who will convince me that everything is fine with the Internet of Things. Can I ask these two persons who kind of fight with me to join me here in front? Yeah, make you some space for your laptops. I don't know, if you want to be on the image, you have to be a little further here. Bernhard and Bernhard and Lukas are joining me here in front. You have seen Bernhard already doing some great Node-RED stuff. He's becoming here my perfect assistant in the lecture. Okay, guys, we should all abandon all work with the Internet of Things and only focus on the classics. True or not true? So our point, I think I've stated our point. Do we want to add something to the doom scenario? Or do we want them to let defend it, right?
No, I think they should come up with some ideas and then we fight.
Okay, good. So I've presented my case. I think there's just too much trouble going on with all the Wi-Fi settings, with all the privacy. It's not worth it. Why is it worth it? Why and how can we fix all the problems we have seen? Please. You all have arguments. If you don't say, I will just pick a random person. Okay, back there. Fight against me.
I think it is worth it because there are a lot of security precautions we can implement in the devices to make it secure, like for instance mandatory updates for the devices.
How do you want to control that? With a government regulation or so?
Yes, for instance, it's required, like for instance, like the data protection regulation from the EU has something like this.
Yeah, there's something recent.
IoT that requires devices to have mandatory updates.
Another point supporting that. What's back there?
Yeah, a point for supporting IoT. Yeah, you have increased health, safety, and accessibility for people. It's like when you have IoT in a hospital, for example, it helps to get people better.
Okay, so you think actually we want Internet of Things in the hospital because the benefits outweigh the disadvantages, yeah? So we'd rather have some people dying from a DOS attack and saving two than vice versa, yeah?
No.
How can we fix the problems for... Anyway, yeah, it's, I think, an easy position to agree with. We don't. But how will we mitigate the problems I had? So I especially had the hospital case. How do we make sure that it doesn't happen in the hospital? That one of your colleagues helps you.
We should ensure that hospitals upgrade to the newest devices and the newest security standards, and the support of insecure algorithms you should get rid of. So
How do you make sure that these devices are?
you enforce them. You give them
I think the problem is
money to actually do it, and for hospitals especially, that would be part of the tasks for a
You are next, but first one of these.
So I think for hospitals this would be possible because health is a critical part of our society, and it would get supported by the country.
Okay. What do you have to say against that?
I think it's a good point, but what if you build a new hospital, equip it with the newest and securest technology, and all of a sudden there is a crack or maybe something broken in this new and secure infrastructure, then you have to just switch all the devices because they are not secure anymore.
So
That's why it is validated before it is installed.
Yeah,
So let's assume the company who builds the devices is actually going bankrupt. Yeah, so happens all the time. So you have now all these kind of heartbeat monitors in the hospital, $1,000 each. And no, actually, look, Nicolas is the next one. But now this company goes bankrupt. There's an open certificate in the network. Some hacker takes the certificate and puts malware on all these things. How do you protect against it?
Could this always be the case? Like, right now, this can always be a threat.
Yeah, that's why we should not. How do you protect from that? Okay, Nicolas.
The most important part is to secure the network, which is already done and should already be done. Because also all the computers in the network have to be secured, and the network itself should be secured. And if the network is independent of the internet, so it's just like a local network and local hardware, it shouldn't be a problem to be always secure. Also, if a company gets bankrupt, because if the network or the protections, the attacking surface is only inside a local network, it's much harder to get into the network and then attack the hardware. So if we secure the network, it shouldn't be a problem.
So you actually say it's not, updates is not the issue. The issue is that we have kind of isolated networks, and so that actually addresses one of the arguments I had in the beginning, where I said, yeah, why do we put all the why is the health monitor on the same network as maybe the Excel sheet which I fill in? Yeah, so this is a little bit the point or two. We want to actually separate the networks and make sure that they are properly secured for how critical the infrastructure is in there. Okay, yeah, good point. I think your neighbor was actually next.
Before they call me
Yeah.
It made the source code
Open source, or it opens it up.
So
Yeah.
there are public audits which can test the code, and if there's a security threat, they can easily fix it.
Okay, I think that is a very interesting point. We kind of create open communities, we use some or some core components, we open source, standardize, and make it auditable. That is a very interesting point. I give you the voice, and then I give it back to my colleagues. Yeah.
In the hospital, I think IoT shouldn't be used as a controlling part of somebody's body, but it can be a benefit if we just monitor like heart rate and things like that, and blood pressure, and there is a notification or something if there's a problem. So it can just be a benefit than just not monitoring it all the time.
So you want to implement a measure which actually helps to detect a threat of the system, or you just want to restrict what you can actually do with Internet of Things in the hospital? Because if you want to do the latter, you should join us here in front. Yeah, I should just elaborate on your point. I don't want to.
I think monitoring is good, but controlling is not that good.
Okay, welcome here. You were kind of working against the other two. Yeah, I agree with you. Totally. We should really restrict the Internet of Things use in the hospital. Okay, what do you guys say?
I think the strength of IoT is that it's so heterogeneous, I think it's called. So there are many manufacturers and different kinds of devices and so on, and the solutions maybe mostly depend on some kind of restriction to combine to restrict to certain firmwares and standards and so on.
Mm-hmm.
But maybe this would just take away some of the strength of IoT.
So you basically say we cannot really overcome the inert property of the Internet of Things, that heterogeneous is being heterogeneous and allowing so many different devices to talk to each other is actually its strengths. But if we allow that, we also get all the problems which come from this heterogeneity. Yeah, because things will not work together. There are lots of mistakes we cannot detect because they only come in a system. And so if we only think in the devices, which we usually do, then that will be very, very bad.
Heterogeneous systems, you have no standardized support for everyone, so you need to fix every problem on its own.
Yeah. Yeah, what do you think? There is a good argument actually against what we just said, but I want you to come up with this. I think the heterogeneity is a huge, and it's in the phone sector, this is called fragmentation, yeah? So I think you guys know better what we are talking about if we talk about fragmentation. How do you address that? Without saying we don't use the Internet of Things. Because if the Internet of Things is inherently heterogeneous. If we take that away, we don't have the Internet of Things, and you have an argument for us. One of the arguments you meant before, the open source stuff, kind of doing a lot of testing, doing a lot of vetting, trying out a lot of systems. So I'm actually working against us now. In kind of trying different combinations fitting together and seeing the use cases, how it fits together, could actually help mitigate the heterogeneity issue there. Yeah? What else can mitigate that? We all talk about devices and say, yeah, we let different devices connect to each other. What is the problem with this? Just talking about devices. This leads to the issues we have just seen. But how can we prevent this? Okay, I have to, you don't come up with it, I will present it a little bit after this here. Do we have any other point to scare them?
Yeah, the point is always if it's connected to the internet or to a company, there's always the problem that the server can go down there. So as it was with the temperature heating system, and there was the server of the company was down, and so nobody could heat up their home.
Nicholas, how has this been solved? You have read about this, haven't you?
The one with the Nest.
Yeah, with the Nest. How was the Nest thing resolved? They just started their server again and it can happen any time again, or have there been some countermeasures?
I'm not sure at the moment, but I can read again about it.
Anybody else found this? Some of you have kind of Googled some threads. Have you found some of the measures companies actually have taken to make things more secure? Or work more reliably?
Yeah, you can have stuff like secure boot, so that you know that the software is not compromised. So
You can actually sign things and
and only allow signs on bootloaders to start up the device. So that way you can make sure that if a hacker injects malicious code, that the secure boot detects it and it can't even start up.
But is this feasible in kind of the microcontroller realm?
For things like in hospitals, it's feasible if you're working with like really sensitive data. I mean, it's not maybe feasible for like home applications like that need to be cheap, but in the hospital infrastructure, I think it's worth doing it.
Okay, you make the scenario-based case. You say kind of basically we have to evaluate where the device is running and then take proper security measures for that environment, and might actually have to give devices a bit more power to deal with the security, yeah?
Yeah, and implement dedicated security chips on in the hardware.
To restart the Nest, there was a 9 9-step procedure, detaching the nest from the wall, then charging it 15 minutes with a plug, trying to restart it again, and it was like kind of depressing, I think.
That's a great solution. That's actually not.
It takes half an hour.
You want to join us here?
But it was just 0.5% of the consumers of the Nest thermostats which weren't fixed before.
And 100,000 people have it, so were 5,000 people affected? No, 500. 500.
I think it's okay to have.
I don't know. I wouldn't be okay with
But
that.
if it's just a half hour.
Okay. Yeah.
I think in general in hospitals, for instance, it would be important that you make sure that you're not dependent on external services or external databases, but at least make sure that you have a plan B if.
Oh, that is a nice point. The plan B. Nobody has mentioned that. You need an exit strategy. You need something. What happens if something is, in jeopardy and kind of attacked? Yeah. But I think that is actually valid even for your own home. So this idea that we need to think, that we need to be aware that there are security issues and that we need to know what we do if some break-in happens, if something stops working, what is actually, there need to be a program for that. So guys, thank you so much for joining me here. Yeah, give them a little bit of applause. There were some very valid points. Thank you to you too. I think you also had pretty good points. And now I switch sides. So let's look at the nice side of things. So I'm definitely not the first person who thinks about that and will not be the last. So there are some really nice papers. I give you actually later some references in the slides. So I have a lot of reading material here. So it's a bit more academic today. So there's actually some textbook advice for companies which plan to build Internet of Things systems. So I think you all probably are scared enough that you believe me that security is an issue. Yeah. So nobody would probably argue with me that you should completely ignore security. So that means we have to emphasize security from day one. Yeah. Security is kind of boring for us developers, but when we plan our scenarios, when we do things, we should think about security in there. Yeah, so at least design also when you construct something, one scenario where things go wrong, because that makes you think about the security. Then you have to build in security in your life cycle. Yeah, so basically make sure you have updates. Make sure there is something planned how updates work. And this it's independent of if the updates come from the cloud automatically or if there is an admin in your hospital who has the right to install the updates and has all the keys or so. But you have to have a plan how to do the updates. Yeah? Updates shouldn't be magical. Updates should be planned. Also, I really like the point with the open source stuff. So for the case that a company goes bankrupt, you want to have access to the firmware. You want to be able to even make some changes and give it to a different company and say, hey, I pay you lots of money to continue developing this stuff. Yeah? Or okay, this is really a dead device. This is a device which has to be exchanged every 2 years, which can be in your plan. But you need to know that in advance. What's going on now? Yeah, then we want to use access control and device authentication, yeah? So just don't do everything in clear text. So also think really of implementing these methods. Know your enemy, yeah? Actually, what we just did now, I think really helps us, or hopefully helps us. So we know some of the common threats and know that actually using Wi-Fi is convenient, but critical. And be prepared, yeah? Have a protocol, have a plan B for security breaches. So that's what textbook says. Now comes what ulno says, yeah? So, yeah, awareness. I'm a teacher, so I say, yeah, this is an important topic to address. So you are all hopefully aware now about this. So I hope in the future you will think about this aspect too when you design an Internet of Things system. And now my big thing. So I'm not a security expert, but I'm a software engineer. So I would actually say I'm good in designing big pieces of software. And I'm also good in designing systems. So systems have architecture. So you have to plan your security on a higher level. Don't plan the security. I mean, it's okay. In an agile system, you can also plan security on the way, but the architecture you use reflects how security threats propagate. And using a star topology again, so just saying, okay, I build one device and let it connect to the internet is not good enough. This will incur security problems, especially in corporate environments. Maybe for home use, we can accept that, but especially the cases I've presented before were mostly targeting home use users. So you want to have some kind of, like your house has a physical wall, there should be kind of different layers in your architecture too. So maybe having a specific router, a specific hub for your house, which only has the home devices in there, or in the factory or in the hospital where only specific domain targeted devices are in there, and there's a natural security layer at this point, is a good thing to model. It's a good thing to put into the architecture. So think about layers. Think about where changes the level of security. Yeah, and sometimes the solution might be avoid wireless communication. Yeah, maybe good old cable communication might solve a lot of issues. Then, in terms of open source, have an active and aware community. Yeah, we want to have probably people who think about it, who deal with this all the time, and have communication between these people. Have an exchange. Allow your users to give feedback. Have a process, have an open GitHub repository where people can audit things for free, or at least have some kind of cooperation or companies which can audit each other. Yeah? But still, I would actually think about making the core of your technology completely open and exposing it to create trust and to encourage people to review it and to ensure future development. And to invest into this community, into this open community, be supportive and say, hey guys, we are open about it. We want you to to be critical about us because then we can make it better, and then again we get more trust from you, and so there will be a win-win situation here. Now, I don't mean you have to open source all your software, but make some stuff of it open so that people can give feedback, and maybe you agree with some companies that you use this open source core. So it happens a lot with Google, Facebook, and even Microsoft now, that they open source some of their core components which are important for all other web portals. And so then the community picks it up, and there's a lot of benefit from this in terms of security, and you find at least some of the mistakes faster. They still happen, but it's easier to address. Okay, and then like before, build security into your lifecycle management, into the maintenance that we already had. And yeah, and think about the encryption. So my case is a little bit, because IoT uses only symmetric encryption, that has some trouble with if you get all the keys, because then you can address it. But as I have a key for each device, okay, you can then compromise this one device, but not the whole network. Yeah? So there might be some big advantage in sometimes thinking about different ways to do encryption in your network, which might be not so clear. We all learned that asymmetric encryption is the best thing since sliced bread, but because of the man-in-the-middle attack problems, might be not always the case, and because of some feasibility stuff, it doesn't work in all the devices. And then if you combine it with layered architecture, you can say, okay, this little part here does symmetric encryption, so everything behind the Raspberry Pi does symmetric encryption, and now we have the Raspberry Pi as the gateway. This does to the cloud then proper certificate validation and is secure. So, and if you have more layers in there, you can do even more fine-grained security measures there, or thinking about update and maintenance. So yeah, you know this guy here, and I support layered architectures. Yeah, that's kind of built in. There are other systems, other opinions. So you want to maybe read about the particle photon idea. They do it different. They do everything cloud-based with really powerful devices, and they manage everything in the cloud. I don't know if I would trust the company to be around all the time. So I have the big question, what happens because their stack is not open? What happens if this company goes down? So yeah, I rather do it my way and be able to manage it locally and still use a lot of open source software which is used in other cases and vetted this way. Again, I think you understood the case, yeah? So we want to have different layers, different gateways, and then the nodes are just at the outside. So in total, it's not the end of the lecture yet, in total, what you should take from here is, let's be very aware of the existing security issues in the Internet of Things. Yeah? We can't deny that there are tons and a lot. But this is actually one more reason why we have to create awareness, why we have to work together to not let this escalate. This will be always there, so it won't go away, but we have to constantly address it to be able to handle it. Also, please take into account that system architecture might be very important about the threat vector, the attack vector, and the security. Yeah, so take it from a systems guy or from a software engineer. We are important. Yeah, so software architecture is important even for security. Yeah, security is also important for us, but vice versa too. So, and I usually finish my talk, this is not the finish of the talk now, but kind of in saying, let's prevent breaking the Internet of Things. And I just have now more than 20 people hopefully helping me in that goal, not to break it too much. So, if you are really interested in what I did, it has all sources, so I actually published the references here. These are all kind of pretty easy read articles. If you like that stuff, take a look. And I think Bernard found something pretty funny. I think the Internet of Shit, maybe that's something you should share with us too, if we could add that to this list here. Okay, then the lab today is not that hard. You want to continue what you've done last time. The scales should work very easily today because I finished the driver of the scale. So just use ulno.net and make sure that the scales everybody has some access to the scales. We have only 3 working ones. So we need to be able to get this. So maybe everybody can have 15 minutes or half an hour with the scale and do their measurements there. So I want that everybody really works on getting the measurements straight today and working on project 2. So nothing else going on today. And if you don't manage today, you have to do that as homework. Okay, I was actually 2 minutes fast today. Isn't that great? So I had a lot of fun. I hope you enjoyed this kind of weird mixture today. And then see you in the labs.